Hello friends, I welcome you in lecture number 38 on higher order ordinary differential equations. In this lecture, we will discuss this question on the method of undetermined coefficients which was asked in GTU Winter 2019 exam. Here we are asked to solve this non-homogeneous linear differential equation using the method of undetermined coefficients. So first we write what is given equation and then we will try to solve this equation using the method of undetermined coefficients. I can write given equation as y double dash plus 2 times y dash plus 4y equal to 2 times x square plus 3 times e raised to minus x, and we give this number 1. To solve the non-homogeneous equation, we are first finding the general solution of corresponding homogeneous equation. So first we solve the corresponding homogeneous equation by considering right hand side equal to 0. Corresponding homogeneous equation is y double dash plus 2y dash plus 4y equal to 0, and the general solution of this homogeneous equation is complementary function of this non-homogeneous equation. To solve this equation, we have to write down the auxiliary equation, and it is lambda square plus 2 lambda plus 4 equal to 0. We recall that auxiliary equation can be written by replacing nth derivative by nth power of lambda, where n takes the values 0, 1, 2 and so on. That is, y double dash is replaced by lambda square, y dash is replaced by lambda, and y means y raised to 0 is replaced by lambda raised to 0, that is 1. And this is clearly square of lambda plus 2. No, it is not square of lambda plus 2. We require 4 lambda for square of lambda plus 2. So we have to see whether b square minus 4ac is negative or not. If we compare with a lambda square plus b lambda plus c equal to 0, we have b equal to 2, that is b square is 4 minus 4, a is coefficient of lambda square, c is constant term, and this is 4 minus 16, that is minus 12, which is negative. Therefore this quadratic equation has complex roots. We know that if b square minus 4ac is negative, then quadratic equation has complex roots, and we have ready-made formula for the solution of quadratic equation. It is minus b plus or minus square root of b square minus 4ac divided by 2a. Here a means coefficient of lambda square, b is coefficient of lambda, and c is constant term. So we substitute all these values here. Lambda equal to minus b, that is minus 2, minus b, b is 2, it is coefficient of lambda. So I am taking b equal to 2 here, plus or minus square root of b square, b equal to 2, that is b square is 4 minus 4, a is 1 and c equal to 4, and 2 times a is 1. Therefore lambda equal to minus 2 plus or minus, this I can rewrite as 4 minus 16, and that is minus 12 divided by 2. Therefore lambda equal to minus 2 plus or minus square root of 12 into I square. We replace minus 1 by I square divided by 2, and we know that square root of 12 is equal to square root of 4 into 3, and that is equal to 2 times root 3. So here we write 2 root 3 square root of I square is I divided by 2, and finally 2 will get cancelled and we have lambda equal to minus 1 plus or minus square root of 3 into I. And if we compare with alpha plus or minus beta I, we have alpha equal to minus 1 and beta equal to square root of 3, and therefore the complementary function is, because we have complex roots, the solutions are e raised to alpha x cos beta x and e raised to alpha x sin beta x, and we put values of alpha and beta here, and we have c1 e raised to alpha is minus 1 cosine of root 3x plus c2 times e raised to alpha x, alpha is minus 1 sine of square root of 3 into x. This is the complementary function of given equation which we have given number 1. Now second step is to determine the particular solution of this differential equation, and for that we have to use method of undetermined coefficients, because they have specified that solve this equation using the method of undetermined coefficients. So we know that method of undetermined coefficient is applicable if we have special right hand sides, that is if we have polynomial function, exponential function and sine or cosine, and linear combination of all these functions are allowed. Here we have linear combination of polynomial and exponential function, therefore we can use method of undetermined coefficients. And the idea of method is, depending upon the right hand side of given differential equation, we have to assume the trial solution, and here right hand side is denoted by Rx, and it is 2x square plus 3 times e raised to minus x. 2x square plus 3 times e raised to minus x. Here I have two functions in the addition. One function is x square, another function is e raised to minus x. Corresponding to x square, the family of derivatives is 1x x square, and corresponding to e raised to minus x, we have only one function e raised to minus x, which will be repeated in all the derivatives of e raised to minus x. And whenever we have two functions in the addition, we will take the union of corresponding family of derivatives. Before taking union, we will check whether any member of this family is present in the complementary function or not, and we can observe that no member of this set 1x x square is present in the complementary function. Similarly, no member of this set is present in the complementary function. Therefore, we will consider union of these two families, and then we will take the linear combination of members of that union. Union means we have to write down all the elements which are present in both the sets. We have 1x x square e raised to minus x, and our choice for particular integral is linear combination of these four functions. Assume that the particular solution of given equation 1 is denoted by y suffix p, a into 1, that is a, plus b into x plus c into x square plus d into e raised to minus x. Whenever we have method of undetermined coefficients, depending upon the right hand side, we can always say that our solution is in particular form, that we decide from the right hand side function. Now once we know that our solution is in this form, The only thing remains is to determine these coefficients a, b, c and d. For that we will put this yp in the given equation, and by comparing the coefficients we will be able to decide these constants or coefficients a, b, c and d. Now our differential equation is of second order, so first I have to differentiate this 2 times, and then I will substitute values of yp, yp dash and yp double dash in given equation. I am differentiating this with respect to x. A is constant, so its derivative is 0. Derivative of b into x is b. Derivative of cx square is 2cx. Derivative of e raised to minus x is minus e raised to minus x, and d is constant. And second order derivative is derivative of b is 0, 2c constant, derivative of x is 1, e raised to minus x has derivative minus e raised to minus x, so we have plus sign here. And now we have assumed that yp is solution of given equation, therefore yp will satisfy given equation. So we can write that yp is solution of 1, therefore we can replace y by yp in this equation. Here I can replace y by yp because yp is also a solution of this equation. So I will have yp double dash plus 2yp dash plus 4yp equal to 2x square plus 3 e raised to minus x. So that I am writing here yp double dash plus 2yp dash plus 4yp equal to 2 times x square plus 3 times e raised to minus x. Let me check again. Our equation is y double dash plus 2y dash plus 4y 2x square plus 3 e raised to minus x. So this is fine, we have written correctly. Now we substitute values of yp double dash, yp dash and yp here, and yp double dash is 2c plus d into e raised to minus x, 2c plus d into e raised to minus x plus 2 times yp dash. Yp dash is b plus 2cx minus b plus 2cx minus d e raised to minus x, and yp is a plus bx plus cx square plus d e raised to minus x, and it is multiplied with 4. So 4 into value of yp, which is a plus bx plus cx square plus d into e raised to minus x, right hand side as it is 2x square plus 3 into e raised to minus x. Now on the left hand side we combine all the constant terms, then we will combine the coefficients of x, then coefficients of x square and terms in which we have e raised to minus x. So first I am writing constant terms, which are 2c and 2b and 4a. So that I am writing directly 2c plus 2b plus 4 times a. This is independent of x and e raised to minus x. Then I am writing the coefficients of x. Here I have this place, I have x, and 2c into 2, that is 4 times c, and here I have bx, that is multiplied with 4, and I have 4c plus 4b x common. Then I combine coefficients of x square, so that also I write in the bracket, and there is no x square here. Here I have cx square multiplied with 4, so I have 4cx square. There is only one term which contains x square, and then I will write down the coefficients of e raised to minus x. Here I have d e raised to minus x, that is d from this. Here I have minus d into 2, that is d minus 2d, let me write all the terms. After that we will simplify. And here I have d into 4, that is plus 4 into d, and e raised to minus x common, and right hand side is 2x square plus 3 times e raised to minus x. Now let me rewrite after simplifying. Here I can rewrite this as it is. Here also I have to write as it is, 4c plus 4b times x plus 4c times x square. Here I have 4d minus 2d, that is 2d plus d, that means 3d e raised to minus x. And here I can write in this way, 0 plus 0 into x plus 2 into x square plus 3 into minus x. And because we have this identity, that is left hand side and right hand side are equal, we can compare the coefficients. First we can compare the constant terms. Here constant term is 2c plus 2b plus 4a, and here constant term is 0. Then coefficients of x, here coefficient of x is 0, here it is 4c plus 4b equal to 0. Then coefficient of x square is 4c here, and here coefficient of x square is 2, so I have 4c equal to 2. Here coefficient of e raised to minus x is 3, and here it is 3d, so we must have 3d equal to 3. Now solving all these equations, we will be able to decide these constants a, b, c, d. From this I can write c equal to 2 by 4, that is c is 1 by 2. And if I take c equal to 1 by 2 here, and I will have 4 by 2, that is 2 plus 4b equal to 0, that means 4b equal to minus 2, and therefore b equal to minus 1 by 2. And from this I have d equal to 1. And from this I can obtain value of a. I have 2 into c, that is 2 into 1 by 2, which is 1, plus 2 into b, that is 2 into minus 1 by 2, which is minus 1, plus 4 times a equal to 0. This will give me 4a equal to 0, that is a equal to 0. b is minus 1 by 2, c is 1 by 2, and d equal to 1. So using all these constants, our particular solution is y equal to a is 0, plus b into x, b is minus 1 by 2, that is minus 1 by 2 into x, plus c into x square, that is 1 by 2 into x square, and d into e raised to minus x, d is minus 1. So this is our particular solution. And once we obtain the particular solution, next step is to write down the general solution, and it is nothing but addition of complementary function and particular solution. It is y equal to complementary function plus particular solution. And what was our general complementary function? c1 e raised to minus x cosine of root 3x plus c2 e raised to minus x sine of root 3 times x, and minus x by 2 plus x square by 2 minus x by 2 plus x square by 2 plus e raised to minus x. And here c1 and c2 are arbitrary constants. So this is easy question, and it was asked in GTU exam, and you can see we are able to solve it easily. We are not having so much calculations, even if we have 4 undetermined coefficients. all we have to take care is to select proper choice or to select particular integral correctly. If our choice for particular solution is correct, then rest of the things are mechanical work. We have to decide the undetermined coefficients by comparing both the sides. So for that, what I have done, I have tried to write down the left hand side in this form: something into x plus something into x square plus something into e raised to minus x, so that I am able to compare both the sides and I am able to decide the undetermined coefficients. So this is all about this session. Keep watching. Thank you.